take two, because I was using the wrong microphone the first time around. Great. Today, let's take these 100-year-old barnwood logs and turn them into some usable lumber. Hey everyone, how's it going? So a couple of years ago, my in-laws renovated their kitchen and dining room, and they asked me to build them a dining room table using some reclaimed barnwood. The dining room table videos will be coming out in the next month or so. You will be able to find those in a playlist up here once that is ready to go. It made sense to me that I am most likely not the only one trying to make something out of reclaimed barnwood, so I decided to break down the process so that you can follow along. I have a fair bit of work in front of me, so let's get into it. Step number 1. Purchase or harvest the barnwood. I could have purchased some previously reclaimed barnwood from, for example, Backroads Reclamation, who you can check out in the description below. Or I could go for a drive in the country and find a farm with an old barn where the farmer doesn't mind me taking a chunk of wall out of it. We went with option 2 since my father-in-law's family farm was relatively close to home and it already had a barn that was falling down that we could harvest. So my wife, her parents, and myself went for a day trip out to the farm to take a chunk of wall out of the 100-year-old barn. From what I can tell, this barn was constructed more like an old log cabin with dowels stabilizing the logs and sheeting on the outside. The sheeting was a little bit thin for my needs, so we ended up leaving that behind, but we did take a bunch of the logs back home with us. Thought we had some footage of attacking the wall with the chainsaw, but I guess not. We ended up taking around 25 or so of these 6-foot logs, and now that I have them, I need to slice them into individual boards. Step 2. Slicing the barnwood. There is a few ways to do this. Method number 1. Just get someone else to do it. If you know someone with a big bandsaw or a bandsaw mill, you might be able to get them to slice the logs into lumber for you. This is what we did for a good portion of the logs, since at the time I didn't have the equipment to do it myself. I contacted Pipestone Timber, who you can also check out in the description below. I ended up taking 14 or so of these logs over there and got them to use their bandsaw mill to slice the logs into roughly 1.5 inch thick boards. If you're going to go this route though, there is a couple things to keep in mind. 1. Make sure that you pull out whatever nails may be embedded, as well as you can at least, to avoid damage to other people's equipment. The bigger those bandsaw blades are, the more expensive they are to replace, so you don't want to be on the hook for that. 2. Factor in travel time to deliver and pick up your material. Pipestone is about an hour away from me, so it was about 2 hours of travel to drop off and pick up the logs, and there was about an hour of just chatting in there too, because, it's always fun to talk shop once in a while. And 3. Your turnaround time. Whoever you take the material to might not be able to get to it right away. I lucked out and Pipestone was able to get the boards back to me within about a week or so. So, yeah, worked out. Method number 2. Buy the equipment and do it yourself. Not saying that you have to get yourself a full-on bandsaw mill. However, depending on the size of your material, you might be able to get away with a 14-inch floor-standing bandsaw with a 3/4 inch 3 TPI blade, teeth per inch. Personally, I upgraded my small benchtop bandsaw with about a 2-inch depth of cut to a freestanding 14-inch bandsaw with a 6-inch riser block, which gave me just over an 11-inch depth of cut. To give the logs a straight-ish first cut, I whipped up a quick jig out of some scrap sheet goods and cut a flat reference face on the table saw. Screw the log down into the jig fence and cut into your log. If you rotate it 90 degrees after your first cut, you'll still have a relatively flat reference surface to work from as you continue to slice the log. If you are going to go this route, 1, again, check for nails. 2, equipment maintenance. You will want to make sure that your blade is sharp, tensioned properly, and the blade guides are set properly. Otherwise, this will be a bit of a miserable time. Don't ask me how I know. An alternative to the bandsaw is an Alaskan mill attachment for a chainsaw. I can't actually speak to this one despite owning one because my chainsaw is too small to work with the one that I have. Wish I had known that before I bought it, but I bought it 3 years ago and I hadn't gotten around to slicing the logs I already have in stock, which is another project video altogether. Which hasn't come out yet even though it's been 3 years. Still working on it. Guess I'm going to have to buy a new chainsaw now. I'm not all that upset about that. Method number 3. Hand tools. Yeah, it's possible. Not something I want to do, so I'm not gonna. Whichever method you choose, you should now have some rough cut lumber at whatever thickness you decided to cut the logs, and that should now be a lot more usable with whatever tools you might have in your arsenal, which helps for the next step. Step number 3, squaring up your lumber. As in making it a square shape. It won't be perfectly square yet. Method number 1, again, get someone else to do it. This one is a little bit more dependent on who you end up hiring to slice up your logs, but you might be able to get them to slice all of the live edges off at the same time and cut it into planks first. However, that might not be an option, and depending on the size of the material, it might be a lot less effective in terms of maintaining the amount of usable material. That would also depend on the equipment being used. So really, it's just a whole lot of dependencies, so your results may vary. Method number 2, table saw sleds. This was my preferred method. Using the live edge decimator I built a few videos back, which you can check out up here, I ripped both long sides of the current batch of lumber straight with the second side just off the table saw fence to give me 4 rough cut, more or less straight edges. Worked out well. Method number 3, circular saw. This one is similar to the table saw sled, however it's a little less costly if you don't already own a table saw. Using a level or some other kind of straight edge, mark a line down the length of the board to indicate your cut location, and send your circular saw down as straight as possible. Then measuring across the board to get a parallel measurement, repeat your steps to cut off the alternate side. Method number 4, hand tools. Again, I'm good not using hand tools, but you could pretty much repeat method 3 and use a hand saw instead of a circular saw to do the same thing. For this next step, depending on the quality of your barnwood, you might be able to skip it. Mine definitely needed it though. You might have noticed so far that this lumber has a fair bit of cracking, checking, bug tracks, rot, etc. So, step number 4, stabilizing your barnwood. So now that you know what it is, if you don't need to stabilize your lumber, you can skip to this timestamp, but we don't mind having you stick around for a while. Why not? Come on. Method number 1, epoxy resin. Admittedly though, before I can start that step, I need some epoxy advice, and I hit up Scott over at the Crafty Wiener, who you can check out up here, and we figured out a plan to make this work. To keep the epoxy in the boards, especially since they are still at the rough stage, I completely enclosed 5 of the 6 sides of the board with some tuck tape. I'm using a couple different eco-epoxy products here since they were what I found readily available to me. For the small cracks, I'm trying the UV epoxy line since it's more designed for coating / low thickness applications with a 20-minute working time and a full cure time of 48 hours. For the bigger cracks, I'm using the Flowcast line since it's more designed for casting and higher thickness applications with an 8-hour working time and a full cure time of 72 hours. Now for the sake of the table build, my first thought was to use some black tinted epoxy to play off the century-old weathering and aging. However, I wasn't sure how well that would play with the bug tracks running throughout the board. Luckily, the tint doesn't affect how you mix the epoxy either way, so mix up the epoxy as per the manufacturer's directions, and once the mixing time is up, you're good to slowly start pouring into the cracks, which took a few days over multiple pours. After the first couple boards were done, I decided not to go with the black tint and to use the Flowcast for everything since it does have the longest cure time. That gave me a lot more infiltration into the board than the UV epoxy did. Yes, it works out to more pours since the wood drinks up more of the epoxy, but I think it gives me a better product long term. Some things to keep in mind here. It will take a lot of time. Like a lot. Each pour takes 3 days to cure. Luckily, the previous pour is solidified enough that you can do another pour after 48 hours or so. The first one will just be a little gummy, or like soft to the touch. Though, considering each board needs 2 to 3 pours, you could be looking at a week's worth of curing time per board. And it's gonna take up space. My workbench is only 2 by 4 feet in area, so I could only fit 5 to 6 boards on it at a time. So considering the time factor, if you had an unlimited amount of space, you could in theory have everything done in a week and a half. Since I needed 50 to 60 individual boards, it took me nearly 6 months to start and stop work on epoxy, finally getting everything filled for the amount that I needed. And it's not cheap. I think I'm at $1,500 Canadian in eco-epoxy alone on this project. It's crazy. And of course, the health factor. Follow the instructions on the bottle. ventilated area, respirator, nitrile gloves, etc. But what if you don't have a bunch of area to fill and the wood is just on the soft side as opposed to falling apart rotten? Well, that takes us to method number 2, cyanoacrylate, or as is known more commonly, CA or superglue. Did you know that CA glue comes in different thicknesses? Let's take 2P10 for example. Thin, medium, thick, and gel. While you could use the latter two, thick and gel, for some minor gap filling, the thin and medium, more thin, can be used more as a penetrating hardener. Pour it on, let it soak in and dry, and you should be good to go. At least on the top half inch or so of the surface. If you wanted to get more deep into the material, you're going to have to get more into method 3. So, method 3. Vacuum or pressure chamber. Now, I haven't had the opportunity to use either of these two options, so take what I say here with a grain of salt. This will also depend on the size of material that you are working with and whether or not it will fit in whatever vacuum or pressure chamber that you have. For the sake of argument, let's say we are using the Flowcast again, and you already have it all mixed up in your container. You take whatever material you want stabilized and you submerge it into the epoxy and you put it into whatever chamber you have. If it's a vacuum chamber, it will pull all of the air inside of the chamber out, which will include any air inside the wood, which will then be replaced by the Flowcast. If it's a pressure chamber, you just pack that full of air, which compresses whatever air inside the wood to take up less space, which forces the Flowcast to fill in the empty space. Like I said though, grain of salt. I know what these do in theory, but I can't actually speak for their effectiveness since, I've never done it. So now that your lumber is stabilized, or it was already stable and you've just rejoined us from step 3, step number 5, actually squaring up your lumber. In step 3, we took the rough lumber and brought it down to a square-ish shape, whereas now we are actually making all of the sides 90 degrees from each other. Method number 1. Like before, get someone else to do it. If you know a local woodworker, you might be able to bribe them with a nice bottle of whiskey to run the boards through their thickness planer or jointer. Never hurts to ask. In my script, this is supposed to be whiskey, but it's 9:30 in the morning, so coffee instead. Method number 2. Again, buy the equipment and do it yourself. Like I mentioned in method 1, the best method would be a thickness planer and a jointer. You can check out this video by James King over at Kingsfied Woodworking to learn everything you need to know about thickness planers and jointers and how they work. I don't own a jointer, so I didn't end up using one. However, you can get by with a thickness planer and a table saw with a couple of jigs. It might be slightly slower, but from what I can tell, just as effective. To joint the wide faces, I just repeatedly ran the boards through the planer to take off 1/16th, 1/32nd of an inch each time, flipping the board each pass to slowly smooth out any differences over time. Then to joint the short sides, if the boards are less than 3 inches tall, you can take them to the table saw again with the live edge decimator. If they are more than 3 inches tall, you can build a jointing jig to run the boards through the planer to joint the short sides. You can check out the jointing jig I built for this project up here. Method number 3. Hand tools. I'm still good. Yeah, it's fine. I'm okay spending the money and getting a little bit faster equipment, but with enough time and determination, it is completely possible to have a perfectly thickness and squared board with enough time and effort. If I only had one board to do, I could maybe be persuaded to go that way, but with the 50 to 60 that I needed, no, not happening. And with that, with those 5 steps, I have taken the rough barnwood to a perfectly squared piece of usable lumber. This is the nicer side. So, is it all worth it? For your super unsatisfactory answer, depends. Like with anything, there is definitely that sweet spot between effort required and desired end product. If I had been able to get more of the epoxy done at one time and the project not taken 2 years overall, it would have definitely tipped more into the worth it side of things than it already was. With that being said, I think I'm going to call this video here, and I will leave the question of whether or not it was worth it up to you as you see the final product coming out over the next couple months. Those videos will slowly be added to the playlist linked up here. And with that, thank you all for watching, and if you like what I'm doing here, give this video a thumbs up and subscribe for more. If you have any questions or comments, I look forward to seeing them and reading them in the comment section below. And if you want to see more up-to-date projects, you can always follow me on Instagram at John the Schreiner. Otherwise, I will see you here in the next video, and have a good one. I like it. Looks good.